laptop. If we take it apart, we will ... touchpad, battery, speakers, cooling fan, and a large computer motherboard. Stored on the solid-state drive SSD. Next to the SSD is installed on the left side of the heatsink after disassembly. Is the computer's brain, the CPU. Structure is mainly divided into 3 parts, with the top part being a heat dissipation protective cover. The layer of points connects the chip is soldered onto the interposer layer, crucial part of the entire computer, containing billions or even tens of billions of transistors. Different functions, such as the 4 on the left. The core components enabling high-performance computing are the GPU cores used for graphics processing, which are part of the energy efficiency core. The components on a chip are very complex. Computing performance has a very complex internal architecture. By the core to the nanometer level is a huge maze, the upper level of which is a densely packed metal wire. As a large number of transistors are further amplified, it consisting of 6 transistors. Chip is composed of various gate circuits, in transistors and logic gates. You can check out my previous videos. Chip contains 16 billion transistors. All those transistors ensure a smooth online gaming experience. Here to understand, we can ... CPU as an analogy. This is a table, calculator, a pen, and a blank sheet of paper on it. It was surrounded by rows of bookshelves, which held thousands upon thousands of books. One next to the desk transports books back and forth, is also equipped with an automated robot. Take the various books it needs from the bookshelf and put them on the trolley. Transports the books back to the table. The robot will place the books back on the table and set them aside. The information from the books on the table and write it down on a piece of paper. For calculation, and can read information from a blank sheet of paper and then proceed. Operations are actually performed on the bookshelf where the books are placed. Like the computer's memory, used to temporarily store the data needed for CPU calculation, and the books on the table are equivalent to the high-speed cache inside the CPU. CPU doesn't need to frequently read data from memory. It improves the CPU's execution efficiency. This is a blank sheet of paper that the CPU's internal registers are mainly. To the instruction address indicates that the executor can access data in the registers. In reading and modifying rows is this calculation. The arithmetic logic unit inside the CPU, which is responsible for performing all arithmetic operations. Operations are the digital heart of a computer. A look at how the CPU performs calculations. We'll read from the instruction pages in the book. That is, the CPU cache. First we loaded from the cache, specifically the first instruction, the load instruction. Is actually quite simple. It simply means assigning the address number 2. Corresponding address number 161 on the page, 174, and then 174 is onto the blank paper, that is, into the register after the instruction is executed. Return to the instruction page and then execute the next instruction. It adds 1 to the previous data entry when the instruction is executed. 70 for previously stored in the register. To the computer logic unit, or will perform an accumulation operation to obtain 175. Accumulation is completed. The next instruction, which is the store instruction, will be executed. Results at address number 161. The arithmetic logic unit will then store the result. Number is 161. That 174 is updated to 175 according to this method. Follow the instructions, executed one by one in sequence until all the necessary instructions were complete. Corresponding to these 3 instructions is only 2. Xcode, the original, similar, except that the instructions to be executed are more complex. Any operation we perform when using a computer, various different codes, like this simple calculation, in C++, only understood by programmers, doesn't recognize it. Computer understand this code. The code is converted into binary. CPU can perform various operations. Our computers to run various different software.